All right, room 50. Welcome to module 2. Today's the very first day of our first module, but does that mean that everything from module 1 we can just forget and then now we're starting fresh? No. As you know, math always builds upon itself. So all the skills you learned about working with decimals and multiplying by powers of 10 and things like that will be very useful to you moving forward into module 2. Okay, so today we're doing module 2, lesson 1, and your learning goal is to be able to use what you know about place value patterns. Wait a second, is that what we learned in module 1, all about place value? Yeah. So you're going to take what you know about that to multiply whole numbers by multiples of 10. In module 1, we learned how to multiply numbers by powers of 10, so like 10, 100, 1,000, 1 million, etc., right? But this time we're multiplying by multiples of 10. What's a multiple of 10? It's like when you count by 10. 10, 20, 30, 40. Is 60 a multiple of 10? Yep. Is 120 a multiple of 10? Yeah. Is 45 a multiple of 10? No. Okay. What do all multiples of 10 have in common? What do all multiples of 10 have in common? Nithya? They end with at least 1 0. Very good. But first, let's talk about the problem of the day. So right now, go ahead and write down this problem you see in blue. 43 times 30. Okay? So the directions say to fill in the blanks using your knowledge of place value and basic facts. Okay. Off the top of your head, do you know your 43 times 30 facts? No. But we can think that 40, and I want you to write everything you see in blue. Okay? So if 43 times 30 is the problem, we can think in our head that 43 ones times 3 tens. Do you guys see that? This is the same thing as 43 ones and 3 tens, right? Yeah. So that's the same as 43 ones times 3 tens. Do you guys agree? Yeah. Is 43 copies of 1 the same thing as 43? Yeah. Is 3 copies of 10 the same thing as 30? Yeah. Okay. Now, when we multiply, thanks to something called the associative property and the commutative property, we can move those factors around, can't we? Yeah. So if I can switch these two and have the value be the same. So this is the same thing as 43 times 3 times 1 times 10. Do you guys agree? Yeah. Okay. Can we do 43 times 3? Yeah. We sure can. If we can't do it in our head, we can write it vertically like this. What's 3 times 3? 9. What's 3 times 4? 12. So what's 43 times 3? 129. Okay, so this is the same thing as 129 times, what's 1 times 10? 10. So therefore, 43 ones times 3 tens is the same as how many tens? 129 tens. Do you see that? Okay. Now, if we have 129 tens, how do I write that in standard form? Meaning no units or anything like that. How do I write that in standard form? 1,290. Yes? So therefore, 43 times 30 is 1,290. Okay, now we have 430 times 30. Go ahead and write that. Now this time when we have 430, is that still 43 ones? No. That's 43 whats? Tens. So we can write that as 43 copies of tens. Yes? Okay, so rewrite it like that. And we still have 3 tens, yes? So that's times 3 times 10. 3 copies of 10. Right? And this time, if we switch these two around, we want to put our factors of 10 together. So now we have 43 times 3 times, is it still 1 times 10? No. This time it'd be times 10 times 10, right? We already know 43 times 3 is what? 129. And this time, 10 times 10 is? 100. So this time, for 430 times 30, we have 129 hundreds. Yes? Yeah. So therefore, 430 times 30 is 12,900. So basically when we're doing this, we're separating out the factors of 10. We can tell there's a factor of 10 because the numbers end in 0. Do you see that? Okay, so this is 43 tens. Now up here for 43, is this a multiple of 10? Because it doesn't end in 0. Is 30 a multiple of 10? Yes. So because it ends in 0. So we're separating out the factors of 10. For 430, we said that was 43 tens, and 30 is 3 tens. And then we're switching around the factors using the associative and commutative property so that we put all the numbers that are not factors of 10 together and all the numbers that are a factor of 10 together. Does that make sense? Yeah. Very good. Let's try some more examples. Let's take a look here. Is 830 a factor of 10? Yeah. Is it a multiple of 10? Yeah. Yeah, we can tell because it ends in 0. So 830 is 83 tens, right? Yep. How can we write 83 tens using numbers? Well, we can write 83 times 10. Do you guys agree that's 83 copies of 10? Yeah. Yeah? Okay. What about 20? Is that a multiple of 10? Yeah. Yeah. It's how many copies of 10? 2. So we can rewrite, we rewrote 830 as 83 times 10, right? 83 copies of 10. And we can rewrite 20 as 2 copies of 10. Does that make sense so far? Yes. Is that the same thing as what we have in our number sentence? 83 tens. Is this 83 tens? Yeah. And then 2 tens. Is this 2 tens? Yeah. Good. Okay. Now, we want to put the numbers using the associative and commutative property. We can move those factors around. So we want to group the numbers that are not multiples of 10 together. What 2 numbers are not multiples of 10? 83 times 2. Okay? And then on the other side, we want all the multiples of 10. What multiples of 10 do we have? 10 times 10. I want you to notice that they're all multiplication because they're all factors. Do you see that? All the symbols there are multiplication symbols. Okay, the book already told us that 83 times 2 is 166. And 10 times 10 is what? 100. So 83 tens times 2 tens is 166 hundreds. Make sure you write the words in your notebook. Is it hundredths or hundreds? Hundreds. Good. Okay, if I'm going to multiply 166 times 100, how does the decimal point move? To the right. 2 spaces to the right. That's the same as adding how many zeros? 2. Okay, so therefore 830 times 20 is? 16,600. Very good. Okay. Take what you've learned there and try this one on your own. You're going to write out the words and the numbers, and you're going to show how you switch the order around to find the final answer. Go ahead and try this one. It's 4,400 times 400. So sometimes in your problem set or your homework practice or your test, you might see this. It says find the products and show your thinking. Do you notice something similar about all those problems? Yeah. They all have an 8 and a 5 and lots of zeros, right? Yeah. Okay, for the first one, let's take a look at that one first. 80 times 5. Are they both multiples of 10? No. No, right? Is 80 a multiple of 10? Yes. So I can separate that out. It's 8 copies of 10. So I can write 8 times 10. And then is 5 a multiple of 10? No, so I can't separate it out. I just write it by itself. 8 times 10 times 5, right? Now I want the numbers that are not multiples of 10 to be right next to each other. What are my 2 numbers that are not multiples of 10, Kish?
10 and 1. Oh, not 8 times 5.
So I can say this is the same thing as 8 times 5 times 10. Do you guys agree? Yeah. Remember, the commutative and associative property says when I multiply, I can shift the different factors around. Can I shift the factors around when I'm subtracting? No. Adding? Yes. Dividing? No. No. Commutative and associative property only say for multiplication and addition, you can move the different numbers around. Okay? Okay, now we're ready to solve. What's 8 times 5? 40. Okay, and then we still have one factor of 10. So this is equal to 40 times 10, which is? 400. Very good. Okay, let's try the next one. We have 80 times 5. What's different this time? They're both multiples of 10. So we can say 80 is the same thing as 8 copies of 10, so 8 times 10. And 50 is how many copies of 10? 5 copies of 10, so 5 times 10. Okay, Mackenzie, if I want to move the numbers that are not multiples of 10 together, which numbers do I have to put next to each other? So I can rewrite this using the associative and commutative property as 8 times 5. Yes? Yeah. Now I've taken care of those 2 numbers. Are the rest multiples of 10? So it's 10 times what? 10. Very good. Okay, now we can do the math. 8 times 5 is? 10 times 10 is? So this is the same thing as 40 hundredths, or in standard form, 4,000. Very good. Okay. How can I write 800 as a number times a multiple of 10? Jithya? You got it. 8 times 100. How can I write 500 as a number times a multiple of 10? Ingrid? Remember, I want one number to not be a multiple of 10. If I write 50, it's still a multiple of 10. So I could do 5. Is 5 a multiple of 10? No. So I could do 5 times what, Ingrid? 100. Good. Okay, and then I want to switch the order of the factors around so that the ones that are not multiples of 10 go together. So Stella, which two need to go next to each other?
100 times 100.
Okay, 100 times 100. Those are multiples of 10, so let's put those together. And the other side, Stella would have which two numbers?
8 times 5.
8 times 5. Now, in the past, we put 8 times 5 first. Does it matter if those come first?
No.
Not really. 100 times 100 is what, everyone? 10,000. And 8 times 5 is? 40. So what is 10,000 times 40?
400,000.
Good, 400,000. Therefore, 800 times 500 is 400,000. Marvin, make sure you're taking good math notes. Okay, let's try this very last one. 8,000 times 50. Okay, if we're going to do 8,000 times 50, let's separate out 8,000 into a number and a multiple of 10. Andrew, what would it be?
8 times 1,000.
8 times 1,000, very good.
5 times 10.
And then the next one would be 5 times 10. Very nice. Okay, Eva, if I'm going to move the multiples of 10 next to each other and then the not multiples of 10 next to each other, what would I have? Arvind, if I have 5 times 8, what does that equal?
40.
If I have 1,000 times 10, what does that equal? 10,000. So I have 40 copies of 10,000. So therefore, 8 1,000s times 5 10s is the same as 40 10,000s. Do you guys see that? Okay, if I want to write that in standard form, that's the same as?
40,000.
400,000. Very good. Okay. When we see a word problem on the slide, we do not need to write down the problem, but we need to write down what the question's asking, we need to write down the important information, and we need to show how we know. So it says, the Canadian side of Niagara Falls, have you guys heard of Niagara Falls? Yeah. It's like a giant waterfall. It's half in New York, half in Canada. Okay? The Canadian side of Niagara Falls has a flow rate of 600,000 gallons per second. That means every single second, 600,000 gallons of water is flowing down the waterfall. That's a lot, huh? How many gallons of water flow over the falls in 1 minute? Okay, what's the question asking us to find? Ananya? Okay, what's the important information? We need to know that it flows 600,000 gallons every second. Okay, so if it's 600,000 every second, and we're trying to find out how much water flows every minute, we have to multiply the second number by what? How many seconds are there in 1 minute? 60. So if I do 600,000 times 60, will that show me how much there is in 1 minute?
Yeah.
Very good. Okay? So now let's use what we learned today to separate these numbers into a number and a factor of 10. So 600,000 is 6 copies of what? Of 100,000, right? Okay. And 60 is 6 copies of 10. Do you guys see that? That 600,000 is 6 100,000s, and 60 is 6 tens, right? Okay, there's 2 numbers in there that are not multiples of 10. What 2 numbers are not multiples of 10 in there? Jaden?
6.
And? 6. Good. So let's put those together. 6 times 6. And what's great about this is we know our math facts. We know in our head already what 6 times 6 is, or at least we should. Okay, so we can say that's 36. But we got to worry about the other side. So our other 2 factors are 100,000 times 10. What's 100,000 times 10? 1 million. Good. So if I have 36 copies of 1 million, what's the answer?